Stop right now and look at the light hitting your screen. You think it's traveling. You think photons are racing from your display to your retina at 186,000 miles per second, crossing that 8-inch gap in a few billionths of a second. Every textbook you've ever read told you light moves. Every physicist talks about the speed of light like it's the cosmic speed limit, the ultimate velocity, the thing Einstein built his entire revolution around. Here's the problems. Light doesn't move. Not really. Not in the way you think about movement. I know how that sounds insane, contradictory. But stay with me, because what I'm about to show you is stranger and more beautiful than anything you've imagined about the nature of reality. The photon hitting your eye right now, the one carrying this information from glowing pixels, doesn't experience time, it doesn't experience distance. From its perspective, if we can even call it that, emission and absorption happen in the same instant, at the same location. The entire universe along its direction of motion is compressed to zero thickness. Light doesn't move through space and time. Light is the thing that defines what we even mean by space and time. And once you see why, you'll never look at a beam of sunlight the same way again. Let me start with something simple. A flashlight. You're holding it in your hand on a dark night, you click it on. The beam shoots out. Obvious motion, right? The light travels from the bulb through the air, hits a tree 50 feet away. You measure it, the light took about 50 nanoseconds to make the trip. Movement, travel, journey completed. Now let's do something Einstein did when he was 16 years old, a thought experiment that eventually cracked the universe open. Imagine you could run alongside that light beam. You speed up, faster and faster, until you're running at half the speed of light. The beam pulls ahead of you, but now it's only moving away from you at half its original speed relative to you. You speed up more, 90% light speed. The beam barely edges ahead, you push harder, 99%, 99.9%. Here's what young Einstein wondered. What happens when you catch up? What do you see when you're running at the speed of light, looking at a light beam beside you? Classical physics said you should see a frozen wave, a stationary electromagnetic field oscillating in place but not propagating, like a snapshot of a water wave that never moves. But Einstein realized something deeply wrong with that picture. Maxwell's equations, the mathematical laws governing electromagnetism, don't allow stationary light waves. They don't exist in the mathematics. A frozen electromagnetic wave is like a married bachelor or circular square. The concept is self-contradictory. So Einstein made a radical choice. He said maybe you can't catch up. Maybe the speed of light is the same no matter how fast you're moving. Maybe light always moves at light speed relative to you, whether you're standing still or rocketing through space at 99% of c. But that creates an immediate problem. How can light always move at the same speed relative to everyone? If I'm standing still and you're running at 90% light speed in the same direction as a photon, shouldn't we measure different speeds for that photon? The answer is yes, we should, but we don't. And the reason we don't is that we're not measuring the same time in the same space. Let me build this carefully, because this is where reality gets genuinely weird. When we say something moves, we mean it changes position over time. Speed is distance divided by time, simple. You drive 60 miles in 1 hour, you're moving at 60 miles per hour. But that assumes distance and time are the same for everyone. That there's one universal clock ticking away, one universal measuring stick, and everyone agrees on measurements. Einstein showed that's wrong, catastrophically wrong. Distance and time aren't fixed, they're malleable. They stretch and compress depending on motion. This isn't philosophy or interpretation. This is mathematical necessity forced on us by the experimental fact that light speed is constant. Here's the mechanism. Imagine you're on a train moving at half the speed of light. You shine a flashlight toward the front of the train. From your perspective on the train, the light moves forward at light speed, call it c. Now someone standing on the platform watches this happen. Classical physics says they should see the light moving at 1.5 times light speed, the train's speed plus the light speed relative to the train. But they don't, they measure exactly c. How is that possible? Time on the train is running slower from the platform observer's perspective, not by psychology or illusion. Actually slower. Clocks on the train tick at a reduced rate, and distances along the direction of motion are compressed. The train is physically shorter when moving than when standing still. These two effects, time dilation and length contraction, conspire perfectly so that everyone measures the same light speed. Let me give you the mathematics without getting lost in it. If you're moving at velocity v, your time dilates by a factor of gamma 1 divided by the square root of 1 minus v squared over c squared. When v is small compared to c, gamma is almost exactly 1. Time runs normally. But as v approaches c, gamma approaches infinity. Time slows toward a stop, distances shrink toward zero. Now here's the critical insight. What happens when v equals c? When you're moving at light speed, gamma becomes infinite. Time dilation becomes infinite. Length contraction becomes total. From the perspective of something moving at light speed, time stops completely. Distance in the direction of motion compresses to literally zero. A photon emitted from the sun doesn't experience the 8-minute journey to Earth. From the photon's perspective, emission from the sun and absorption in your eye happen at the exact same moment, separated by zero time across zero distance. The photon doesn't age. It doesn't travel through duration. The concepts of journey and elapsed time are meaningless for light, so when I say light doesn't move, I mean this literally. Movement requires time. Movement is change in position during an interval. But light experiences no interval, no duration elapses for it. It exists in an eternal instant, a frozen now connecting emission and absorption. Let's zoom out and see what this means for the structure of reality itself. We live in what physicists call spacetime, a four-dimensional fabric where 3 dimensions of space and one of time are woven together. Massive objects like you and me move through spacetime on trajectories called world lines. These world lines tilt. We move through space as we move through time. We're traveling into the future at 1 second per second, and we can also move through space at various speeds. But there's a cosmic speed limit, a maximum tilt to your world line. You can trade your motion through time for motion through space, but there's a constraint. The technical way to say it, your forward velocity through spacetime is always exactly c. You're always moving at light speed through spacetime. When you're sitting still, all that motion is through time. When you move through space, you sacrifice some time motion for space motion. Light represents the extreme case. Light tilts its world line at 45 degrees in spacetime diagrams. All space motion, no time motion. Light travels through space at c, and therefore travels through time at 0. It doesn't move through time at all. Now think about what this means for causality. When we say light carries information from the sun to Earth, what we really mean is light connects events in spacetime. The event of fusion in the solar core connects to the event of a photon hitting a chlorophyll molecule in a leaf. Those events are linked by a null geodesic, a light path. From our perspective, 8 minutes separate them. From the photon's perspective, they're the same event. Same time, same place. The universe is threaded with these null geodesics, these light paths connecting events at zero proper time. They're the fabric of causality. They define what can influence what. If 2 events are separated by less than the time light would take to travel between them, they can be causally connected. If they're farther apart, they're causally independent. Light paths are the boundary between connected and disconnected events in spacetime. And here's something even stranger. Consider a photon emitted from a distant galaxy 13 billion light-years away. From our perspective, that photon has been traveling for 13 billion years, crossing unfathomable distances, its wavelength stretched by cosmic expansion. But from the photon's perspective, emission and absorption happen now, simultaneously. The photon experiences the entire history of its journey as a single instantaneous event. Every photon that's ever reached Earth from the cosmic microwave background, from the most distant quasars, from stars that died billions of years ago, experienced no time between emission and arrival. The 13 billion year journey of cosmic light is a journey only from our external perspective. For the light itself, the trip is instantaneous. Let me push this further, because the implications are almost unbearably strange. We think of light as a messenger, as something that carries information across the void. The sun shines, photons race across space, and we see the sun as it was 8 minutes ago. But that framing assumes light moves through time. It doesn't. What's really happening is this spacetime contains events. Some of those events involve the emission of photons. Others involve the absorption of photons. The structure of spacetime, specifically its light cones, determines which emission events can connect to which absorption events. Light doesn't travel between events. Light is the connection between events. It's not a thing moving through spacetime. It's a feature of spacetime's geometry. Think about it this way. When you look at a star, you're not seeing delayed information from the past. You're seeing a direct geometric connection in the four-dimensional structure of reality. The emission event at the star and the absorption event in your retina are connected by spacetime geometry. They're parts of a single causal structure. This is why physicists sometimes say the photon is its own antiparticle, why photons don't have a rest frame, why they're fundamentally different from massive particles. A photon doesn't have an internal clock. It doesn't experience duration. From its perspective, and yes, perspective is the wrong word, because perspective requires a reference frame and light doesn't have one, but from its perspective, the universe along its path is one-dimensional. A line of zero length. Imagine you're compressed in the direction of motion to zero thickness. Everything in front of you and behind you along your path occupies the same point. That's what the universe looks like at light speed. Not that you'd see it, because seeing requires time to process information, and there's no time. Now let me tell you something Feynman himself thought about. He imagined a different way to think about electron behavior. Suppose an electron moving forward in time is mathematically identical to a positron moving backward in time. Then particle-antiparticle pair creation and annihilation are just one electron changing its direction in time. The electron is moving forward, emits a photon, and reverses direction. Now moving backward in time is a positron. Later it emits another photon and reverses again. This sounds insane until you remember that photons don't experience time. From the photon's timeless perspective, the emission and absorption happen at once. The electron moving forward and the positron moving backward occupy the same event from the photon's point of view, because in effect lose their temporal ordering when you step outside time. I'm not saying this interpretation is correct. I'm saying it's possible because photons transcend time. They exist in a realm where our intuitions about sequence and causality break down completely. Let's bring this back to something concrete. You're sitting in sunlight. Photons are hitting your skin. They were emitted from fusion reactions in the sun's core, but those reactions happened in a region where quantum mechanics governs everything. The sun's core doesn't emit photons directly, it's far too dense. Instead, gamma rays are emitted, absorbed, re-emitted, absorbed again, scattered billions of times. A photon, or rather, the energy that eventually becomes a photon, takes hundreds of thousands of years to random walk from the core to the surface. But once it reaches the surface and escapes into space, something changes. Now it's a real photon, not scattered anymore, traveling through the near vacuum of space. And from that photon's perspective, the 8-minute journey to your skin takes zero time. The moment it leaves the sun's photosphere, it arrives at your skin. Instantaneous. Except here's the thing from your perspective. 8 minutes elapsed. The photon moved through space. It had a speed. It traveled. Who's right? Both of you. That's the profound weirdness of relativity. There's no privileged reference frame. No God's eye view from outside space-time that tells you what really happened. Your time frame says the photon traveled for 8 minutes. The photon's time frame, or lack thereof, says the journey was instantaneous. Both descriptions are equally valid. Reality doesn't prefer one over the other. This is what physicists mean when they say space-time is relative. It's not just that measurements depend on motion. It's that time and space themselves are not fundamental. What's fundamental is space-time, the four-dimensional structure, and different observers slice that structure into space and time in different ways depending on their motion. Light sits at the boundary. It's the knife edge where time stops and space collapses. It's the limiting case of motion, the asymptote you can approach but never reach. And here's why you can't reach it. To accelerate something with mass to light speed requires infinite energy. That's not a technological limitation. That's a fundamental feature of space-time geometry. As your speed approaches c, your mass effectively increases toward infinity due to relativistic effects. More accurately, the energy required for each additional increment of speed increases without bound. You'd need infinite energy to reach c. The universe doesn't have infinite energy, so massive objects can't reach light speed. Only massless particles can move at c. And if you're massless, you must move at c. There's no in between. Photons, gravitons, gluons, all massless, all moving at c, all experiencing zero proper time. This raises a fascinating question. Why does the universe have massive and massless particles? Why not everything massless moving at light speed experiencing no time? Or why not everything massive moving slower than light, experiencing duration? The answer has to do with the Higgs mechanism, but that's another story. The relevant point is this mass is what allows particles to have a time direction, to experience duration, to change and evolve. Massless particles are frozen in an eternal now. They connect events but don't experience the connection. So what does this mean for you? Sitting there, made of massive particles experiencing time, it means you're in the minority. Most of the universe's information transfer happens via massless particles, photons mostly, but also gravitons. Most of the connections in spacetime are these null geodesics, these timeless links. The electromagnetic force which holds atoms together, which is responsible for chemistry, for life, for everything you see and touch, operates via photons. Virtual photons technically, but photons nonetheless. The forces shaping your body operate outside time. The photons mediating electromagnetic interactions between electrons in your molecules don't experience duration. From their perspective, the interaction is instantaneous. You are a massively parallel collection of interactions happening at zero proper time, assembled into a structure that does experience time, held together by forces transmitted by particles that don't. You're a time-experiencing pattern made of timeless interactions. Let that sink in. Your moment-to-moment existence depends on processes that don't experience moments. The binding energy holding your atoms together, keeping you from disintegrating into a cloud of particles, is transmitted by entities that don't age, don't change, don't move through time. And when you look at the stars, you're not seeing the past. You're seeing a timeless connection. The light from Alpha Centauri, 4 years old by your reckoning, is 0 seconds old from its own perspective. The ancient photons from the cosmic microwave background, released 380,000 years after the Big Bang, 13.8 billion years ago by our clocks, experienced no time in transit. They were emitted and absorbed in the same instant from their frame. The universe is stitched together with these timeless threads. We move through time, aging, changing, evolving. But the very fabric of causality, the connections that let us influence and be influenced by distant events, exists outside time. Now let me circle back to the title claim and sharpen it. When I say light doesn't move, I mean, this motion is change in spatial position over time. But for light, the time variable is undefined. It's not that time equals zero, it's that time isn't a meaningful concept. The proper time along a light-like world line is not zero. It's null. It doesn't exist as a quantity you can measure. This is different from saying something happens instantly. Instant implies a duration of zero, which is still a temporal concept. No proper time means time itself is inapplicable. The photon doesn't experience an infinitely fast journey. It doesn't experience a journey at all. The concepts of fast, slow, during, before, after, all of these require a temporal framework. Light exists outside that framework. From our external perspective, light moves. We measure its speed. We track its position over time. We use it to define our meter and our second. But that's our temporal slicing of spacetime. The photon itself doesn't participate in that slicing. Think of it like this. Imagine you're watching a movie. The film consists of still frames, 24 per second, each one a frozen snapshot. The frames themselves don't move. They're static images. But when played in sequence, they create the illusion of motion. Motion emerges from the sequence, not from anything in the individual frames. Light is like a single frame. It doesn't participate in the sequence. It connects one frame to another, but it doesn't experience the transition. We, moving through time, experience the sequence. We see motion. We see light traveling, but the light itself is the connection, not the thing moving. Einstein struggled with this. Even after publishing Special Relativity in 1905, even after showing that time and space are relative, he kept returning to the question of what light experiences. In his later years, he talked about riding alongside light beams, about what the universe looks like at light speed. His colleagues told him it was a meaningless question. Light doesn't have a reference frame. But Einstein's intuition was that there should be something it's like to be a photon, some perspective from which the universe makes sense. There isn't. Not in the way he hoped. The photon perspective is the perspective of no time, no extent along the motion axis. It's not a perspective we can inhabit even in imagination, because our imagination operates in time. We can't conceive of an experience with zero duration, because conception itself requires duration. But we can understand it mathematically. The Lorentz transformations that relate different reference frames become undefined as velocity approaches c. The gamma factor goes to infinity. Time dilation becomes infinite. You can't transform into the photon's frame because there is no frame to transform into. The mathematics breaks down not because our equations are wrong, but because the question is malformed. This is one of those rare cases where physics tells us not just what is, but what cannot be. It's impossible, not technologically impossible, but logically impossible, to move at light speed if you have mass. It's impossible to have a reference frame moving at light speed. These aren't limitations of our current understanding. They're features of spacetime geometry as fundamental as the fact that triangles have three sides. Let me give you something you can test. Take two atomic clocks, synchronized to billionths of a second. Put one in an airplane, fly it around the world, bring it back, compare it to the stationary clock. The traveling clock will be behind. It experienced less time. This isn't theoretical. This has been done. The clocks disagree by exactly the amount relativity predicts, based on the plane speed and the change in gravitational field. Now imagine doing this with something moving at 99% of light speed. The time difference would be dramatic. 10 years on Earth could be less than 2 years for the traveler. At 99.9%, 10 years could be less than 6 months. At 99.99%, 10 years could be a couple weeks. At exactly light speed, 10 billion years would be 0 seconds. The entire history of the universe from the perspective of a photon is a single moment. Every photon that's ever existed from the Big Bang to now experiences its entire existence as one eternal instant. This is not metaphor. This is not interpretation. This is what the mathematics of spacetime tells us. It's as certain as anything in physics can be. Light doesn't move through time because light defines the boundary where time ceases to apply. So look again at the light on your screen. You see it moving, and from your frame it is. But the photons themselves, if they could speak, if they could remember, would tell you they never moved at all. They were emitted and absorbed in the same timeless now, across a distance of zero, connecting your retina to the display in a geometric relationship that transcends temporal flow. We think of light as fast, the fastest thing. But fast is a temporal concept. Fast means covering distance in little time. Light doesn't cover distance in little time. It covers distance in no time. It doesn't move quickly. It doesn't move at all. From its own absence of perspective, what moves is your reference frame through space-time. You're sliding through duration, 1 second per second, and as you slide, you intersect these null geodesics, these timeless connections. You interpret those intersections as light moving past you. But what's really happening is you're moving through a space-time threaded with eternal, instantaneous connections. This is the deepest truth about light. It's not a thing that travels. It's the thing that makes travel meaningful. It's not something moving through space and time. It's the structure that defines what we mean by space and time in the first place. Distance is what light crosses in zero proper time. Duration is what elapses for massive objects between light-speed connections. Light doesn't move through the universe. Light is the universe's way of connecting events that can influence each other. It's the causal structure made manifest. It's the geometry of reality, not a thing moving within that geometry. And somehow, impossibly, we massive time-bound creatures built of these timeless interactions have figured this out. We've probed the boundary where time stops. We've done the mathematics. We've run the experiments. We've confirmed that our universe is stranger, more subtle, more beautiful than we ever imagined. The next time you see a beam of light, remember it's not moving. You are. You're sliding through space-time at 1 second per second, intersecting timeless connections, interpreting geometry as motion. Light sits still in an eternal now, connecting emission to absorption across zero subjective time, holding the universe together with threads that don't age. That's the truth about light. It doesn't move. It connects. It defines. It simply is, timelessly and eternally, the living geometry of causality itself.